Okay, last one, question 2016, question 6. Based on this, very miscellaneous here. It doesn't really belong to a certain FRQ. But you might be able to see these in your FRQ exam this year, okay? So just keep that in mind. They give us a variety of values. We'll get to it, okay? They introduce that k is f of g of x, okay? So they want us to write the equation of a tangent line. So let's start there. Equation of a tangent line for the graph of k at x equals 3. You need two things. You need a point and you need a slope. Okay? So I know the point, the x-coordinate is 3, but I need to know what k of 3 is. Right? Okay, so let's check it out. K of 3 is really just f of g of 3. Now, what's g of 3? Let's take a look at the table here. G of 3 is 6. So here we go. Now I know that k of 3 is equal to f of 6. Well, what's f of 6? It's all given right there, okay? So I know that k of 3 is equal to 4. All right? So I have a point, 3 comma 4. All I'm missing is the slope. Slope of a tangent line is really just a derivative. So here we go. K of x is f of g of x, but notice how f of g of x is a composition or a function within a function. So we're going to have to perform the chain rule. K prime of x is the derivative of the outside of the same inside times derivative of the inside. That's our general slope. Specifically, we want to find the slope at x equals 3 here. So k prime of 3 is equal to f prime of g of 3 times g prime of 3. Okay, here we go. G of 3 is 6, so that's f prime of 6. And g prime of 3, according to our table, is 2. Well, what's f prime of 6? F prime of 6 is 5 there. So that's going to equal 5 times 2, which is 10. Okay, you have a point, you have a slope. You got y minus 4 is equal to 10 times x minus 3. No need to get y by itself, okay? Okay, here's part B. They introduce a new function, h, but now h is g over f. Find h prime of 1, okay? So here it's going to require the quotient rule. I really don't like the score guidelines here because they skip a lot of steps. So let me walk this through with you guys. Before you plug in 1, any value, find the general one first. The biggest mistake I see people do every year is they tend to plug in their numbers too early. Okay? So just wait until you actually find what you're looking for first. So h prime of x, I'm going to have to apply the quotient rule here because I have a quotient. That's going to be the bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. Okay? And then once you do that, you plug in 1. Okay? So I'll leave the rest for you guys to do, but f of 1, g prime of 1, g of 1, f prime of 1, all of these values here are in the table. You plug it in and then you're done. No need to simplify the rest, okay? Here's the last one here. Evaluate the integral of f double prime. Okay, so what the heck is f double prime doing here if you have no information about it, right? What happens when you integrate f double prime? You get f prime, right? Okay, so just keep that in mind. But look, there is a function within a function. So what we're going to do is we're going to let u equal 2x. So du would be 2 dx. Okay, so right now my 2x is going to be replaced by a u, but then I have to account for this dx here, and I don't have a perfect fit. So dx, if I move the 2 over, it's going to be 1/2 of du. So here we go. I'm doing this here. I'm using u substitution so I can make my integral look a little bit easier. So this is going to be f double prime of u, and dx is equal to 1/2 du, but I could put the 1/2 on the outside. So the thing is, when you turn everything in terms of u, your bounds will change in terms of u as well. I know that u is equal to 2x, and x right here is equal to 1. So if you let x equals 1 here, u is going to equal 2. And if you let x equals 3 here, u is going to be 6. Okay, so here we go. That's going to be 1/2. The integral of f double prime of u is just f prime of u from 2 to 6. Okay, what do you do next? You plug in your upper. F prime of 6 minus f prime of 2. Well, what's f prime of 6 and f prime of 2? You guys can find that out in the table here, okay, which I'll leave for you guys to do. But when you plug that in, you're pretty much done. Okay?